Managing post-anthesis nitrogen to reduce leaf burn and increase grain protein in wheat. We have been studying the efficacy of post-anthesis applications of nitrogen for at least 3 years now. The most common approach is to apply 30 pounds of nitrogen per acre either as a dribble-banded application of UAN or as a diluted broadcast spray of UAN cut in half with water to reduce leaf burn. Similar to other studies, we have observed a range of results. We have seen a grain protein increase between 0.5 and 1%. However, sometimes the boost in protein was no better than if we had just put all the nitrogen down at seeding. We have also done work with dissolved urea, which is often referred to as melted urea, and is supposed to be softer on the crop than UAN. We have observed this to be true. This picture, for example, was taken from one of our trials in 2019. On the left, you can see the speckling on the leaves caused by broadcast applications of UAN, whereas the broadcast spray of melted urea has done a lot less damage. Despite this, we haven't observed better efficacy with melted urea in terms of grain protein or yield relative to UAN. Although we have often seen a protein boost from the practice, it has rarely been determined to be economical. In my opinion, split applications of nitrogen to increase grain protein should be looked upon as a rescue treatment, not purposeful management. Most of the time, it does not pay to hold back the nitrogen at seeding, unless you can accurately predict the weather, and if that's the case, you should work for Environment Canada. However, a producer may find they have a bumper crop coming with a yield potential that is higher than what was originally planned for. In this situation, low grain protein is of concern, and a late season application of nitrogen may have some value. In this study, we had a number of concepts we wanted to demonstrate. We were not successful in demonstrating some of these, which frankly has me scratching my head. The first objective was to see if we could increase grain protein with 30 pounds of nitrogen per acre applied post-anthesis, and we did accomplish this. And in some cases, we were able to increase protein beyond what was accomplished by just side-banding all the nitrogen down at seeding. Now, we had also hoped to demonstrate melted urea was safer on the crop than UAN, and that spraying in a cool evening would also result in less leaf burn than spraying in the heat of the day. For some reason we didn't accomplish that one. But for me, there was some interesting implications, which we will discuss. Now, let's catch up with Heather in Swan River, and she'll take us through what we did, and then I'll try to make some sense of the results.
The treatments for this trial are listed in the table. Treatment 1 and 2 are checks, with treatment 1 being 70 pounds per acre and treatment 2 being 100 pounds per acre of side-banded N. Treatments 3 to 10 look at 4 different methods of applying 30 pounds of nitrogen per acre post-anthesis, either during a cool evening of 14 degrees Celsius on July 15th, or in the heat of the day the following day on July 16th at 25 degrees Celsius. All post-anthesis applications of N were on top of 70 pounds of side-banded N per acre. The methods of applying post-anthesis N were a dribble band application of undiluted UAN at 28% nitrogen, a broadcast spray of diluted UAN at 14% nitrogen, and then broadcast sprays of melted urea at either 14 or 9% concentration of nitrogen. The dribble banding was done with 3-hole nozzles, and the broadcast spray was done with flat fan nozzles. The trial established well with 329 plants per meter squared. Unfortunately, we had a drought, and only 50 millimeters of precipitation fell between May and June. The long-term average for this time frame is 131 millimeters. When averaged across all treatments, the wheat only yielded 35.5 bushels per acre, and the grain protein was a whopping 17% because of the drought. Here's what the wheat looked like on the day of post-anthesis application. Now here's Mike, who will attempt to interpret the results.
First of all, there were no yield differences detected between any of the treatments. This was not too surprising, as yield potential was limited by the drought, and the post-anthesis applications of nitrogen were late enough not to affect yield. However, significant differences in grain protein and flag leaf burn between treatments were detected. This figure shows the resulting grain protein from each method of applying post-anthesis nitrogen. The red bars are the checks. The first red bar represents the resulting grain protein when 70 pounds of nitrogen per acre are side-banded without any additional post-anthesis nitrogen. When 30 pounds of post-anthesis nitrogen was applied to the base rate of 70 N, every method of application, as represented by the blue bars, resulted in higher protein. But what about just putting all the nitrogen down in the sideband at seeding? Well, that's the second red bar, and you can see that every method of application still resulted in higher protein. However, only these values are statistically greater. What these methods of applications have in common is that they were all applied in the heat of the day at 25 degrees Celsius. Let's explore this further by looking at the main effects of nitrogen timing on grain protein and yield. When averaged across method of application, applying post-anthesis nitrogen during the heat of the day at 25 degrees Celsius resulted in 0.36% more protein compared to applying the nitrogen in the cool of the evening at 14 degrees Celsius. This was not necessarily the expected result. Sometimes applications of post-anthesis nitrogen can increase protein by causing more leaf burn and decreasing yield. Anything that decreases yield usually increases grain protein. But that's not the case here. The daytime spraying has slightly less yield than the nighttime spraying, but the difference is not large or statistically significant. In addition, the nighttime spraying actually resulted in more leaf burn. Flag leaf burn was rated to be 38.1% for the nighttime spraying, which is significantly more than 28.2% for the daytime spraying. Now, this leaf damage includes damage from the fertilizer burn and drought stress, as it was difficult to distinguish between these damages. However, leaf ratings for the check, which weren't sprayed with fertilizer, shouldn't have any fertilizer burn, and yet the damage on those leaves was 17.6%. So any level of damage above 17.6% can be attributed to fertilizer burn. Of course, we weren't expecting the flag leaf burn to be worse from an evening application. Spraying in the cool evening should have resulted in less leaf burn. We were also expecting less flag leaf burn from the dissolved urea compared to the UAN, but this was not observed either. These are the main effects for the method of post-anthesis application on the flag leaf burn, and they are not significantly different. The melted urea does not have lower levels of leaf burn as expected. Overall, broadcast applications of nitrogen increase grain protein relative to dribble band application of UAN, without lowering yield. The superior performance of broadcast application implies leaf absorption of nitrogen may have played a role in increasing grain protein. This is a contentious issue, as Western Canadian research has found most of the nitrogen from broadcast applications is washed off leaves and taken up through root absorption. However, US and European work considers N absorption through leaves to be quite significant. Some have suggested that broadcast applications may perform better during drought because leaves can provide an alternative route for absorption when soils are dry. While we did receive 29 millimeters of rain 5 days after application, the depth of dry soil may still have been a barrier to root uptake. Whatever the reason, dribble-banded nitrogen was less effective than broadcast sprays in this study.
So, from this study, we were able to significantly increase grain protein, even in a drought. However, you'll have to tell me if it's worth increasing grain protein from 16 to 17% over a 34 bushel crop, particularly if protein spreads are likely to be narrow in a season like that. Broadcast applications of post-anthesis nitrogen were more efficacious, and surprisingly, we saw no advantage to spraying at night or using melted urea. As a final note, if you do decide to try melted urea, ensure the product has less than 1% biuret. Otherwise, you will really burn your crop. I am told most of North American production should be fine, but it's better to check and be safe than sorry. Finally, I'd like to thank Adopt for supporting this project.